Let's run a thought experiment. One moment, every rock, building, and human being on Earth stops moving with the ground beneath it, but the air keeps going at whatever speed it was already traveling. The immediate result is catastrophic, and what follows afterward is stranger still. Start with the numbers. Someone standing at the equator is currently being carried around Earth's axis at roughly 1,670 kilometers per hour, about 465 meters per second. If the ground suddenly quits moving while the atmosphere doesn't, that entire mass of air is now screaming across the surface at nearly 465 meters per second. Sound travels through air at about 343 meters per second, so this wind wouldn't just be fast, it would be faster than sound itself. This isn't a narrow band of destruction either. Anyone living within about 42 degrees of the equator, which covers roughly 85% of humanity, would find themselves inside supersonic wind shear. Ground friction would eventually slow the lowest layers of air, but eventually here means a handful of minutes, and a handful of minutes at those speeds is more than enough to erase most of what humans have built. And the danger isn't only the wind, it's what the wind is carrying. Even a structure engineered to survive 1,000-kilometer-per-hour gusts head-on would still have a problem. The building next door. If your neighbor's house isn't as sturdy as yours, it becomes a supersonic missile aimed straight at you. Structural integrity is meaningless if the guy upwind didn't invest in the same contractor. Take a city like Tokyo, sitting comfortably north of the most extreme wind zone. Its winds still wouldn't be gentle. They'd run roughly double the intensity of the fiercest tornado ever measured on Earth. Buildings wouldn't just lose their roofs, they'd be ripped from their foundations and dragged across the terrain. Push all the way up to the northernmost permanent settlements. Small Arctic outposts near 78 degrees latitude. And conditions would still match the strongest hurricanes humanity has ever recorded. There is no populated place on the planet mild enough to dodge this. Yet extinction isn't on the table. Most of the carnage happens at or above ground level, so anyone underground, basements, subway tunnels, mine shafts, would likely ride it out. And there's one truly charmed location: the South Pole. Since the surface there sits essentially on Earth's rotational axis, it was never moving relative to that axis in the first place. Researchers stationed there would feel nothing unusual at all, at least not until they noticed the sun had frozen in place overhead and started wondering what exactly had happened to the rest of the planet. Meanwhile, the oceans would be undergoing their own transformation. Hurricane-force winds ripping across open water would shred the surface into mist, blurring any distinction between sea and airborne spray. That churning wouldn't stay violent forever, though. Friction converts kinetic energy into heat, and there's a lot of kinetic energy to convert. Ocean water below the surface sits at a chilly, steady few degrees Celsius, so as that cold water gets flung upward and mixed with superheated air, you'd get explosive evaporation and condensation, essentially triggering enormous thunderstorm systems across every ocean basin simultaneously. The wind's momentum wouldn't just vanish either. It would get shoved into the water itself, generating waves that circle the globe west to east. Every coastline facing that direction would take a hit resembling a permanent rolling tsunami, with surges capable of pushing seawater miles past the normal shoreline. Now for the long-term weirdness, Earth's rotation is genuinely gone, which means the day-slash-night cycle as we know it disappears too. The planet would still orbit the sun, so instead of one sunrise every 24 hours, you'd get exactly one per year. Practically speaking, that means roughly 6 months of continuous daylight baking one hemisphere, while the other freezes in 6 months of uninterrupted night, brutal heat on one side, deep cold on the other, with a slow crawl of a sunset between them. Here's the twist, though. The atmosphere's own momentum doesn't just disappear, it gets transferred right back into the solid Earth, nudging it to start spinning again. Because air is so much lighter than rock, this new spin would be glacially slow. One full rotation relative to the distant stars would take on the order of 3 millennia. And there's a second, much older mechanism working in the background: the moon. Lunar gravity has been very slowly stealing Earth's rotational energy for billions of years, which is why days have been lengthening over geologic time while the moon drifts to a higher orbit. With Earth's spin abruptly zeroed out, that same tidal relationship would begin nudging Earth's rotation forward again, however faintly, while the moon itself gives up a little orbital altitude in exchange. Given enough time, an almost unfathomable amount of it, the moon would be quietly rebuilding the very rotation this whole scenario just destroyed.